why do you look so down?
I want to prepare for the NMMS, but I have no idea where to start.
Oh,
Don't worry, I'm here to help. Gory Smart Channel has everything you need for NMMS prep. Just check it out. Subscribe, like, and share.
Really? That's awesome. I'll subscribe to Gowrie Smart Channel right away. Thank you so much.
Hi friends, I'm Gauri Shankar. You are watching Gauri Smart Channel. Today we are going to discuss about data handling. This data handling lesson is very important for NMMS exam and SSV exam also. Definitely 2 or 3 bits will be coming from this lesson. Let us do. Before going to start the video, please like this video and please share this video to all your friends. Let us see. Data handling means we have to handle the data. See, in our family, our father handling the responsibility of our family, isn't it? So like that, the data should be handling. So data only handling. How to represent data and how to do the sums in data and how to find some values in data. These are called, and how to arrange in a systematic way. This everything coming under this data. Now, what is raw data? Raw data means the collection of information. The collection of information is called data. That is raw data. The collection of information is called data. That is also called as raw data. Means, for example, in my class, I am collecting the marks of students in mathematics exam. For example, I conducted a maths exam. In that exam, 10 students. So, I am conducting exam for 10 students. So, I am collecting that data. The first student got 15 marks out of 20. The second student got 10 marks. The third student got 8 marks. The fourth student got 16 marks. The fifth student got 2 marks. The sixth student got 7 marks. And next student got 12 marks. And next student got 20 marks. And next student got 18 marks. And next student got 14 marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 10 students' marks data I have collected. This is called raw data. This is called raw data. Next, types. The data is what we are collecting, the observations. These are called observations. The collection of information. In the information, what are there? Observations are there. The observations we are collecting, those observations are again 2 types. That is, so it means the data is again of 2 types. That is primary data and secondary data. If you go and if you collect directly, that is called primary data. If you go anywhere and if you want any information and directly you are asking them and directly you are writing and directly you are collecting that information, that collection is called primary data. If anyone coming to you and the same information is collecting from you, then that is called secondary data. So means already I have collected, I have drawn, I have written each and everything. That the second person or third person is copying from me. So he is not going to directly. So he is what I have collected, that is he is collecting. Means already collected data is collected by another one. That is called secondary data. That is called secondary data. For example, I have collected these marks. This is my primary data. I have recorded in my record. Someone came to me and he has taken the same record for his book. That is called secondary data because he is not collected the marks from the direct students, isn't it? So, primary data and secondary data. And these observations I am keeping like this. Means it is not in a proper order. Means this is called ungrouped data. Again, data is again of 2 types. For representation purpose, for representing purpose, data is again is 2 types. Whatever the collection is there, whatever the collection of the observation is there, that is we are not arranging in a proper order, we are taking as usual, that is called ungrouped data because we are not grouping anything. So we are making same like that only. So this is called ungrouped data. This is called ungrouped data. For this ungrouped data, if I arrange in a systematic way, then that is called grouped data. For example, see here, serial number and class interval and frequency. This everything I will say one by one. So, say everything will be coming under one by one. Now, let us see. And tally max. For better understanding, I am going to give some more examples, then you can easily understand. Again, I am collecting from 10 students, 10 more students. So, 11 marks, 16 marks, 20 marks, 6 marks, 7 marks, 8 marks, 12 marks, 20 marks, 14 marks. So, and one more, 9 marks. So, again I am collecting 10 more. So, total I have collected 20 students. Now, see here, this ungrouped data I want to make grouped data. So, if I want to make grouped data, means what I have to do? I have to make the groups. So, means the 20 marks I have to divide into some groups. Then that is a easy way to find how many students got below 20 marks, how many students got above 10 marks. For the purpose, for analysis, for analyzing the data, for reasoning, for finding the reasoning, for finding the logics, we can make the ungrouped data into grouped data. Now, let us see here. I am dividing the marks 1 to 5, 6 to 10, 11 to 15, 16 to 20. 4 groups I have made. So, serial number 1, serial number 2, serial number 3, serial number 4. Now, these 20 marks I am dividing into 4 groups. That's what this is called grouped data, because I am making the groups, isn't it? So, 1 to 5 and 6 to 10 and 11 to 15 and 16 to 20, isn't it? Now, frequency. This everything I will say. Frequency. Now, see 1 to 5, how many students got? Let us see. 1 to 5. 1. Only one student got, means is failed. So, out of 20, 5 marks means failed only. So, one student failed. Next, 6 to 10. So, 1, 2, 3, 4, 5, 6. 6 members. Next, 11 to 15. So, 10 is also there, 7. Now, 11 to 15. So, 1, 2, 3, 4, 5, 6. 6 members. Now, 16 to 20. So, 1, 2, 3, 4, 5, 6. 6 members. See, if you add, you should get 20, because you are collecting 20 information, 20 observations. So, 1 plus 7, 8, 8 plus 6, 14, 14 plus 6, 20. Now, your information is correct. Whatever the information you collected, that is correct. See, the data what I have collected, that is I am representing in systematic way. Isn't it? Now, what about tally max? Tally max means, see, 1. Here, I am collecting small numbers. If my data is more, means if I collected 1000 members or 500 members or 600 members, means I can't count like that. So, then what can do means, 7 means, see here, 6 to 10. 6 to 10 means year 1. So, 1, next year 1, 2, next 6 to 10. Year 1, next year 1, next year 1. So, this is, I can do like this, means this is 5. This is 5. Next, here 1 and one more. 10 also is there. See, 1, 2, 3, 4, 5, 6, 7. Means this is called groups, some groups. So means bundle, we can say bundle. So that 5 numbers, so 5 observations you make a one bundle, means like that 5 table is enough. So if you have 3 bundles, 3 5 is 15 observations. If you have 7 bundles, 7 5 are 35 bundles. So like that. So if how many bundles you have, that many 5s, then remaining you can add. So for that purpose, means by for getting confusion, we are making tally marks. Next, this is 6. 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4. If you do like this also no problem. If you do cross like this also no problem. Both are same. 6. So these are the tally marks. These are the tally marks. So see here, this ungrouped data I am making into a systematic way, into groups, into some groups. So this systematic way or tabular form, this is called grouped data. This is called grouped data. Now see, everything coming under this table only. Everything, every concept is coming under this table only. Let us see here. Types completed. So grouped data, ungrouped data, primary data, secondary data. Now frequency. What is frequency? Let us see here. Here I am making groups. If I don't make groups, if I write like this, so 1, 2, 3, 4, 5, 6, 7 and so on 20. These are the observations. These are the observations. Now, I want to check one mark students, how many are there? 1 mark students, how many are there? No, 0. 2 mark students, how many are there? 1 student is there. 3 mark students, how many are there? 0. 4 mark students, how many are there? 0. 5 mark students, how many are there? 0. 6 mark students, how many are there? So 1 student. 7 mark students also 1. 8 mark students also 7 mark students 2. 8 mark students 1. So like that 20 mark students. So 1, 2, 3. See here, an observation is occurring how many times? How many times? Number of the times of the observations, how many times it is occurring, it is coming. That is called frequency of the observation. Frequency of the observation. Frequency is nothing but, so we are now going to learn about frequency. Frequency is nothing but an observation which is occurring, the number of the times, how many times it is occurring, how many times it is coming, that is called frequency. Now see, 20 mark students 3 times getting. So 20 marks are getting 3 times. The frequency of 20 observation is 3. Frequency of 20 observation is 3, isn't it? Next, the marks of 7 marks. 7 mark students, how many are there? 2 members are there. Means the marks of 7 frequency is 2. The marks of 7 observation is 2. So that is called frequency. In the same way, if you make groups also, from 1 to 5, how many students are there? From marks 1 to 5, how many students are there? 1 student is there. That is the frequency of this class interval. Frequency of this class interval. Class interval also I will say. Next. 6 to 10 marks. From 6 to 10 marks, how many students are there? 7 marks. 7 members. Means the 7 is the frequency of the 6 to 10 marks. So from 6 to 10 marks, the 7 is the frequency. Next, from 11 to 15, how many students are there? 6 students are there. From 16 to 20, how many students are there? 6 students are there. So these are the frequencies. Means an observation, how many times it is repeating, that repeating value is called frequency of the observations. An observation, how many times it is repeating, that repeating value is called frequency of the distribution. How many times it is repeating, that number is called frequency of the observation. Next, tally marks. Tally marks completed. So the observation, for avoiding confusion, for avoiding little bit confusion, or for writing the correct number of the frequency, we are using tally marks. Using tally marks only we will write frequency. First of all, we have to write tally marks. Using tally marks only we will write frequency, isn't it? Now see here, I am writing like this. Now after that, 1, 2, 3, 4, 5, 6, 7. Now I will write 7 as a frequency. So means for writing frequencies, tally marks are used very well. For writing frequencies, so tally marks are very, very widely used, isn't it? Next, class intervals. Class intervals. The observations what we have collected, if you make the observations into groups, into some groups. Each group is called class interval. Each group is called class interval. For example, I collected 20 marks in mathematics exam, in maths exam. In this maths exam, I am dividing the marks into some groups. Means 1 to 5 marks, means from 1 to 5 marks, from 6 to 10 marks, from 11 to 15 marks, from 16 to 20 marks. These groups are called class intervals. These groups are called class intervals. In the class intervals, so limits will be there. Means these extreme values, what I am taking, limit means the marks minimum is 1, the maximum marks is 5. In this group or in this class interval, I am taking minimum marks and maximum marks. If minimum marks is there, I will take. If maximum marks, below maximum marks only if they get, then I will take them. Otherwise, I won't take them. From 1 to 5 means I have to take from 1 to 5 marks only. I should not take 6 to 10 or 11 to 15 or 16 to 20. I have to bound this 1 to 5 only, isn't it? These are the class interval. Means every class interval is having limits. Its limits means minimum marks, maximum marks. Every time I'm saying minimum marks and maximum marks. Means here these are the limits we can say. For example, 1 to 5 only I'm taking. These are the lower value, so we can say lower class interval, lower class limit or lower limit. Simply we can say lower limit. These are the highest marks in this class interval. This is the upper limit because highest value, so upper limit. Lower limit and upper limit. So 1 to 5 means lower limit, upper limit. Lower limit is 1, upper limit is 5. Now if I take this is class interval, then lower limit is 16, upper limit is 20. In your exam, SSV exam or NMMS exam, they will give 6 to 10 and 11 to 15. For 6 to 10, what is the class interval? What is the lower limit? What is the lower limit? You have to write 6. What is the upper limit? You have to write 15. For example, in your NMMS exam or SSC exam, 6 to 10 and 11 to 15. These two class intervals they will give. Now they will ask like this. The sum of the lower limit of first class interval and upper limit of the second class interval. See how logically they are asking. The sum of the lower limit of the first class interval and upper limit of the second class interval. Means you have to understand lower limit of the first class interval 6 and upper limit of the second class interval is 15. So total is 21. Answer is 21. They will make you confused. So 6 plus 10, 16 is the first option. Next 10 plus 11, 21 is the second option. And 6 plus 11, 17 is the third option. 15 plus 11, 26 is the fourth option. Like that they make you confused. But we got the answer 21, 21 only we have to keep, isn't it? So like that they make you understand. Next boundaries. See here, boundaries. What is the difference between limits and boundaries? Both are same. But some logic is there. See here. Now these class intervals again I am writing like this. 1 to 5, 5 to 10, 10 to 15, 15 to 20. Here 0 will take. See here 0 to 5, 5 to 10, 10 to 15, 15 to 20. 0 to 5, 5 to 10, 10 to 15, 50 to 20. Isn't it? See if I take the class intervals like this, means there is no 5 after 6 we are taking like this. So 10 after 11, 10 we are taking like this. 15 we are taking in this class interval. If I make these class intervals like this, then these are called boundaries. See here. In this, 5 is called lower boundary and 10 is called upper boundary. Means here, these class intervals are inclusive class intervals. These class intervals are exclusive class intervals. Means if I get 10 marks, here I can include. So means these are called inclusive class intervals. These are called exclusive. So means if I get 10, so I have to get 10 marks here only. I should not keep here. So that's what means we are excluding 10 marks here. So that's what these are excluding. These are inclusive class intervals. Means for excluding class intervals only, we are using boundaries. For exclusive class intervals only, we are using boundaries, isn't it? For inclusive class intervals, we are not using boundaries, only class limits. So limits, lower limits, upper limit. Here also we can say 10 is the lower limit, 15 is the upper limit. Here also 5 is the lower limit, 10 is the upper limit. But here we can't say, this is 6 lower limit only. That is not lower boundary, because here it must be 11 or it must be 10. Then only we can say 6 is the lower boundary, isn't it? So you have to remember like this. If excluding class intervals are there, then we can use boundaries. If excluding class intervals are not there, then we can use limits. Understand? Next. Width or size of the class. Width, size of the class. See here, 5 minus 4, 1, 4. 10 minus 6, 4. 15 minus 11, 4. 20 minus 16, 4. The difference of the upper limit and lower limit, that is called class size or width of the class. Size of the class or width of the class. The difference of the upper limit and lower limit. For example, this is I am taking. So 10 minus 6, that is equal to 4. This 4 is called size of the class or width of the class. Next. Height of the class. Height. See, the difference of the lower limit of one class and lower limit of its preceding class. That is called height of the class. For example, 16 minus 11, 5. 11 minus 6, 5. 6 minus 1, 5. 20 minus 15, 5. 15 minus 10, 5. 10 minus 5, 5. So means the difference of the two consecutive class intervals, lower limits or upper limits, that is called height of the class. Next, frequency distribution. Now see here, this everything is our observations. That observations we are making into some distribution. The observations we are making into some frequency distribution. Means the observations 1, 7, 6, 6. Like that we are making distribution. So means for making observations, given data, raw data or primary data, we are making into some tabular form or some table form, then that is called frequency distribution table or frequency distribution, we can say frequency distribution. So making the observations into some frequencies, then that is called frequency distribution, or making the given observations in systematic way, representing the given data into systematic way, then that is called frequency distribution. Next, graphs and types are there. So graphs and types. Pictorial graph. So we can represent the data into pictorial graphs, or bar graph, or double bar graph, or pie chart, or histogram. So there are 5 graphical representations are there. There are presentation, means diagrammatic representations are there. Those are called graphs. Now in this, first we have to learn pictogram. So pictogram. In the olden days, what happened means, they are manufacturing cars and bikes and bicycles. So many vehicles they are manufacturing. So that manufacturing, how many vehicles they are manufacturing, they want to know. So in olden days, this analysis of data, this everything is not there. So that's what they introduced pictogram. So pictograph we can say, pictograph. For example, in olden days I am saying means 1990, 1991, 1992, 1993. So these 4 years they have mentioned like this. See here. one car representing, one car is representing 100 cars. For they want to represent the data, isn't it? So means 200. This is 200 total cost. So in 1990, they have manufactured, one company manufactured 200 cars. Think this is a car. Understand? In olden days, the ambassador cars like this will be. So that's what. So in the next year, they have manufacturing 400 cars. The next year. So definitely it will be increasing. See here, 400, and this is half of the car. Half of the car means they represented 450. Means one car is 100, half of the car is 50. So that's what 450. So see here, they have manufactured 600 and some extra cars means 30 like that. So they have represented below 54 means 630. So in the like this they have represented, this data they have arranged in systematic way. Now they will write here year, cars, number of the cars, or here we can say quantity. See here, the data they have represented years and pictures. What they have mentioned, cars, car pictures means they manufacture cars. So that's what these are the cars they have represented. If they are manufacturing cycles, they represent cycles. If they are manufacturing biscuits, they represent biscuits. One biscuit is equal to 100 biscuits, or one biscuit is equal to 10 biscuits. If they are representing cell phones, so one cell phone is equal to 100 cell phones, or one cell phone is equal to 50 cell phones, or one cell phone is equal to 10 cell phones. Like that, they are representing pictures like that. So this method is very useful in those days, olden days. Then what happened means, if they are manufacturing extra, means this is the scale we can say. What the scale? This is nothing but scale. So one car is equal to 10 cars. One car diagram is equal to 10 cars, like that. So this is the representing scale. We can say representing scale. The scale, if they are making extra, they can't properly represent the scale. Means see here 30 cars extra, how can they represent? One full car is 100, then half car means 50, that's okay. Then what is the 30? Means the exact diagram they can't do, isn't it? The exact diagram. That's what this is failed. So the advanced graph representation is coming. That is called bar graph. What is bar graph? The same data now they can represent like this. See here. This is 1990, sorry. This is 1991. This is 1992. And this is 1993. Now they can easily represent. See here. 100, 150, 200, 250, 300, 350, 400, 450, 500, so 550, 600, 650. Now they can easily represent. In the 1990, 200 cars means one bar, one rectangle they have drawn. So for like this. In 1991, 400 means double. So for 1991, 400 drops, 400 cars. For 1992, 450. Exactly they can represent. Exactly. See here. Next 1993, 630. So 630 means this is 600, this is 650. So in the middle is 625. So in the small far if you distance if you move, then definitely it will be 630. So this is called bar diagram, bar graph, we can say, bar graph. In the bar graph, what developed is there, what are the number of the number you have to represent, whatever the number you want to represent, then that can be easily represented in the bar graph. That can be easily represented. In the pictograph or pictogram, we can't represent some values. That's what in the bar graph we can easily represent. The observation should be on horizontal axis and the frequency should be on vertical axis. So these are the observations. These are the observations. These are the frequency. These are the frequency. So like that, on horizontal and vertical line, if you are representing observations and frequency, that is called bar graph. That is called bar graph. By seeing the bar graph, we can represent or we can conclude that, so in 1992, how many cars are produced, how many cars are developed. In 1993 is the more graphs. In 1990, that is the less car, because in this initial stage, start stage. So like that, by seeing the bar graph, we can easily narrate the stories. We can say anything about that company, isn't it? Next, double bar graph. Double bar graph. See here, double bar graph means for same company. See here, for same company I am saying. So 1991, 1992, 1993, 1994, for example. What they have done, so the same company producing white cars and red cars. Same company, white cars and red cars. See here, this is 50, this is 100, this is 150, and this is 200. This is 250. Now see here, white cars they produced 50 and red cars they produced 100 in the first year. In the second year, white cars are 100 and red cars are 150. In the third year, what they have making, white cars are 70 and red cars are 120. In the last, what happened means, red cars are, the production of, means the purchasing of red cars are decreased. So then what have done means, white cars are 200 and red cars are only 100. See here, the data I am representing here, production of cars only. But here, two cars means two bar graphs. We are making the graph into two bar graphs. Means one is white car, one is red car. For representing data very easily means, so white car I am leaving that only, red car I am making dash. For understanding easily. Means here we can write, this is a white car. This is red car. Red car. Means by seeing this data, we can say which car is more production in that year. Which car is more production in that year. And which car is less production in that year. See, by comparing all years, 1994, the white car production is more than the red car. In the 91, 92, 93, the production of the red car is more than the white car. Isn't it? Means what we are doing, we are comparing white cars and red cars. So the comparison between the production of two cars, we are representing here. We can represent this is in marks also. For example, in your class, your teacher is conducting format 1, format 2 marks, isn't it? So the teacher can conclude of 10 students or 20 students by using bar graph, double bar graph. So format 1, format 2, format 1, format. So like that, student 1, student 2, student 3, student 4, student 5, student 6. Like that, she can make. So marks will be in the vertical axis, isn't it? So she can say, so which student is a betterment is there from format 1 to format 2, which student is not performing well in format 2 than format 1. Like that, the teacher can represent the data using double bar graph. Next, histogram. Next what? Histogram. What is histogram? See here, very easy histogram. We are taking horizontal line and vertical line. So this is called horizontal line and this is called vertical line. Now, whatever the class intervals are there, these class intervals means exclusive class interval if I take, so 0, 5, 10, 15, 20, 20 only. So these marks if I take on y-axis means what? 1, 2, 3, 4, 5, 6, 7. If I take, now see, 1 to 5. 1 to 5 how many? Only 1. Means rectangles I will take. So 5. Next, 6 to 10 or 5 to 10. How many? 7 members. Next, 10 to 15. 6 members. Next, again 6 members. Now see, I am representing my observations or my data in a rectangular form. These are also rectangle, but in this rectangle some gaps are there. See here also some gaps are there. But here if you observe, there is no gaps between any rectangle. The width of the rectangles are same. And there is no gap. Means, if you take the class intervals on x-axis and frequency on y-axis, if you take class intervals on horizontal axis and frequency on vertical axis, if you draw a rectangles, then that is called histogram. In the histogram, if you make midpoints and if you draw a curve, smooth curve, that is called frequency curve. So this is called histogram. In histogram, they will ask definitely one bit. In NMMS or SSV, they will ask one bit. What is the bit? Which of the following are correct? The widths of the rectangles are different. The widths of the rectangles are same. The heights of the rectangles are different. The heights of the rectangles are different. So like that they will give. You have to choose the correct answer. The widths are breadths we can say. The widths of the rectangles are same. So here how much width is there? Here also that much, here also that much. Here. Because we are taking class intervals, that is exclusive class intervals. So those are equal. So that's what the class intervals are equal. So widths will be also equal. That is called histogram. Next, pie chart or circle graph we can say. Now see here, if you make a circle, you know sector. What is sector means? The space which is occupied by 2 radii of the circle and the arc which is joined by the endpoints of the radii. Is called sector. So like that sectors if you take, if you divide the whole circle into some parts using sectors, then that representation of data is called pie chart or circle graph. Here in the circle, the sum of the angles at the center is 360 degrees. Here how to get values means, this value means they will give some value. This value by this total value, this means some particular value by total value. Into 360 degrees. Why 360 means this total 360. How much this angle we want means we have to multiply this 360. That is called angular sector. Angle of the some sector. Angle of the one sector. One particular sector. So means if you want any sector means that particular value by total value into 360 degrees. That is gives that sector angle, the angle of this sector. If I take this angle means this value. So this value will be representing something. So this value by this total value into 360 degrees if I say, if I do, then I can get the angle of this big sector, the angle of the big sector. Means the parts, each and every parts representing one thing. Means for example, I mole is there. For example, here I am starting. My time I am dividing, my time. Total how many hours are there? 24 hours are there. 24 hours. For everybody 24 hours will be there. For morning, natural cost, everything, for riding, school, everything, I will spend 2 hours. Next, after that, I am going to school. In my school, I am spending 7 hours. So 2 plus 7, 9. Still how many are there for me? 15 hours are there. 15. Isn't it? Now, again I'm coming to home. I'm making videos and I'm making editing. This everything I will take 5 hours. And the remaining 10 hours, I'm sleeping. I am sleeping. Isn't it? See here. 2 plus 7, 9, 9 plus 5, 14, 14 plus 10, 24, isn't it? This 24 hours I am representing in a circle way. So means what? This is called natural activities. This is called school hours or school time spending. This is called editing and studying, and this is called sleeping of my daily activities. So my daily activities I am representing in a circle representation. So I am representing a sector representation. So this is called pictograph or circle graph. Pictograph or pie chart. We say, sorry, pie chart or circle graph. Pie chart. This is called pie chart. Now how can get values? How can I get values? See here. Now this is how much angle making. I don't know. So what is I tell? This angular sector is nothing but 2 hours by total 24 hours into 360 degrees. Isn't it? 2 ones are 2 12s are. Again 12 ones are 12 threes are. Now see, this is 30 degrees. This sector is representing 30 degrees angle. Out of 360 degrees angle, this sector is representing 30 degrees angle. 30 degrees angle. So like that, we can do anything. We can do anything like that. So we can do anything. So like that every angle will be coming. So actually 24 multiples if I take, then I can get 30 degrees, 50 degrees, 40 degrees like that. Some of the all angles will be 360 degrees like that. So you understand? So this is 30 degrees, this is some degrees, this is some degrees, this is some degrees. Total degrees is 360 degrees. So like that we can represent the data in a circle graph or pie chart. So these are the everything we covered in data handling, and also data handling grant test will be there tomorrow or day after tomorrow in our description. Please write in that exam also, and please share this video to all your friends because very less views are there. I'm not getting interest to make the videos. Please make this video to all states, not only in Andhra Pradesh, not only in Telangana. So make in other states also, means Gujarat, Gandhi and Himachal Pradesh, next Karnataka, Tamil Nadu. These all states are there. Please share to your all other countries or other state friends. Then it is very useful for all, and also I'm also getting more interest to get more videos, isn't it? So if you like this video, please like it. If you have any doubts, please comment it. And if you are the new student to my channel, please subscribe my channel and please share this video to all. Thank you very much. Bye bye.
If you enjoyed this video, please like, subscribe, and share it.